Hi, everyone, and thank you for coming to our Ask a Geologist program. So today with us, we actually have Michael Schwab, who was an education coordinator at the Meteor Crater in Arizona. However, we are having some technical difficulties, so you won't be able to see him on the screen, but he is here on speakerphone, so I apologize for any audio quality. So he will be speaking to us, and we are going to hear what he has to say. So without further ado, Michael, you can go ahead and get started.
Hello, everyone. Hope everybody's doing well. Thank you, Ria, for the introduction. But yeah, my name is Michael Schwab. I was working at Meteor Crater as the education engagement coordinator and as a tour guide. And yeah, let's get started on my favorite place. Oh, well, hold on. Let's talk about me first because nothing's better than talking about me. I have worked at the Walters Art Museum in Baltimore, Maryland. I've also worked at the Liberty Science Center in Jersey City. I've also worked at several of the Smithsonians here in Washington, D.C. And I've also worked at Meteor Crater. That's why we are all here today. But fun fact about me, I absolutely adore dinosaurs. And trying to figure out which one of the dinosaurs I know is my favorite is kind of difficult, but I did narrow it down to one. My favorite is actually Sue. I will not say Tyrannosaurus Rex. If you don't know the story about Sue, then you're missing out. You should look it up. But without further ado, some background information, because I found a lot of times that people get confused as to what the heck a meteor is versus an asteroid. And that's fair, because I did a lot of that myself before even working there.
What
is a meteor? Well, a meteor is essentially a small planetary or small object in space that's leftover scrap material from the beginning of our solar system. So it could be materials like rocks that are pulled together, could be materials like iron and nickel pulled together, and it essentially can be a small object. Whereas asteroids tend to be those larger planetary size objects that we all hear about that sadly kill. But yeah, where do they come from? Well, one theory is that these objects are leftover materials from the beginning of our solar system, which is actually one cool fact for later in this presentation. So remember that. The leftover scrap material. But most of the ones that hit our planet come from the asteroid belt. And for whatever reason, whether it's collisions with other objects in the asteroid belt or gravitational pulls that cause them to move, some of them end up on a trajectory course towards us. Thankfully, we haven't had a massive impact ending one for a while. That's good. But yeah, why is it so impactful? Well, couldn't resist a good pun, could I? It's impactful because one theory is that these objects brought in necessary materials to form our atmosphere, form our planet, but it's also impactful because these materials can also kind of give us a date as to how old our planet is. I'll touch on that in a second. Just keep that in mind. It's all a loop around. Now, I haven't had a massive impact for quite a while. This impact here in Arizona happened somewhere between 50 to 60,000 years ago. Now, those that are concerned whether or not that actually killed any human beings? No. At this point in our human history, we actually didn't have any humans yet living on this continent, which is good. Nobody was harmed by that. But unfortunately, that's why we have that date range between 60 to 70,000 years. Nothing exact. Because those human beings were not yet here to witness that impact. I like to put dates on things because I'm annoying and gonna flex my history past. So I like to tell people that this happened July 4th, 50,000 years ago. And that this would then be the best fireworks show that we never got. That the crater didn't actually appear in any historical records until very late. Until the 1870s in our historical records. And the reason why it becomes apparent once you get out to Arizona, especially in northern Arizona. The closest water source to this site is actually about 20 miles away. And around the crater, it can get really hot very quickly. There's not a lot of shade because there's no trees on the Colorado Plateau up there. And it's just brutal. So most of the time it appears that if there's going to be a settlement in the area, it's going to be hovering around water sources. But it was marked down in the 1870s when in fact the Army was out scouting out the area. And it was passed off as nothing more than a joke because the Army didn't quite believe that the scout who found it was actually telling the truth. I guess they thought he was out in that Arizona sun for a bit too long. Now, the first geological study of the place actually happens in the 1890s. So about 20 years later. But that's good and actually very interesting because it being passed off as a joke in the 1870s meant that people didn't go out to go visit it. So in that first geological study, they had a lot of evidence still very well preserved and intact. Nobody was coming out and looting it because nobody took it seriously. But people actually came out to visit it because there were reports of iron and nickel meteorite fragments being found in the desert. And within these fragments were also bits and pieces of diamonds as well. So understandably, diamonds are kind of exciting for people. So the USGS decided to investigate whether or not this was actually an impact site. And if it was an impact site, it was going to be the first one to be proven and documented. But what's remarkably interesting about that study in the 1890s is that the USGS didn't actually believe that this was an impact crater. Because they actually believed that in order to be an impact site, the meteor would actually survive impact, intact, and still reside at the bottom of the crater. So in fact, that's actually what they were looking for. We know now that the meteorite and its fragments vaporized and the remaining parts of it were dispersed for 7 miles in every direction from the site. So it's really no wonder that they never found that evidence. But they had to come up with a reason for the formation of this crater. It didn't just fall from the sky and form magically, no pun intended. They actually came up with the idea to tie its formation in with the surrounding geology. And if you ever go out to northern Arizona, you'll actually see that there are a bunch of volcanoes in the surrounding area, in particular around Flagstaff. Gotta love Flagstaff. But that's actually where they come up with the idea of the crater being formed. They call it a volcanic steam vent, and it actually stays scientifically identified as the cause of the crater from the 1890s on that first study all the way up to the 1960s. Really not all that long ago. But its history doesn't really stop there, nor does its importance, because it's obviously an impact site. But how the heck did we get there? I'm glad you guys asked me that question. Because in 1903, a man by the name of Daniel Barringer actually decided he was going to buy the site. Now, why on earth would he want to do that? Well, he had the idea that this actually was an impact site. He had an experience in mining, and he noticed that in the surrounding area that the rock layers were actually overturned. Rock layers were overturned, and that there was a large absence of any volcanic debris in the area. How can this be a volcano without that debris? But mixed in with that overturned rock layers as well are fragments of meteorites, which Daniel Barringer figured means that these two were deposited approximately at the same time. But being that Daniel Barringer was human, there's mistakes being made. Because Barringer actually thought that there was a very large meteorite somewhere at the bottom of this crater. So he too bought into that idea of meteorites surviving impact. So that's actually what he was looking for, because he opened the site up as a mine. And he began mining that site in 1903. And by 1929, he decided to close up shop after spending a total of $7 million in today's money at that location. Now, it wasn't all just a business venture for him to try to find that meteorite, because while he is mining there, he's taking studies of the site. He's inviting scientists to come out and do studies of their own to try to get the ball rolling on this being identified as an impact site instead of volcanic activity. And that's important because it helps us later on down the road to the 1960s. Now, in the 1960s, a geologist by the name of Shoemaker actually comes out to study the crater. And Shoemaker is a rather interesting individual because he has a brand new perspective on this whole site. Because Shoemaker is actually studying the nuclear test sites in Nevada. And he sees similar geological features at those nuclear test sites to the ones that are being documented by Daniel Barringer and his team at Meteor Crater. So Shoemaker actually goes out and studies Meteor Crater himself. And he actually believes and proves, based on some of the geological material there, that this is, in fact, an impact site. Now, what's also great about Shoemaker, getting a landmark change should be enough on somebody's resume. But what's great for Shoemaker is that he also then gets to train the astronauts. And I've very frequently got questions out there as to why the heck are the astronauts even coming out to the middle of the Arizona desert? Great question. Let me answer that for you before I get to that. Before you get to that. Now, it may surprise some of you guys to actually know that we've only had one geologist go to the moon, which means that all the rest of the astronauts that have gone have no geological backing at all. But they're going to be asked to identify the cause and formation of each one of those craters out on the moon. So that's actually, in fact, where Shoemaker comes in. Because using his work and his understanding of impact sites, he actually gets to train them in geology and the geology of impact sites. He then takes them to the other formations like Sunset Crater National Park, which is also in the surrounding area, and teaches them to identify volcanic activity. Then to places like the Grand Canyon, and to other places like the Lowell Observatory. So, why is it that we care about a big hole in the ground? Well, Meteor Crater is the first proven impact site. So, thanks to that, we actually get to understand other impact sites. Because we now know what we're looking for thanks to the Meteor Crater. It's super well preserved because it's in the middle of the Arizona desert. It hardly ever has any rain out there, although it does rain. It has rained quite a lot this year. Holy cow. It does not have any harsh environments like wind, rain, snowfall. It doesn't have water eroding it away. Its main source of erosion is predominantly just the wind. But some of those local desert foliages, such as juniper bushes, for example, help hold it in place, and by and large keep it very well preserved for us today, which means we can see a relatively young crater, understand its formation and the geological features within it, and we then take that to study other ones, like impact sites such as Chicxulub, which some of you may know is the one that killed the dinosaurs in Mexico. So believed. But I said it does snow. There is rainfall. I was not lying. There's a really great panoramic of it for you all. But if you guys ever do go out to the Meteor Crater, and I sure hope you guys do, one thing that sits in the actual museum is this meteorite on the screen here. It is called the Holsinger meteorite. It is actually the largest fragment of meteorite recovered from that site, and it wasn't actually found inside the crater. That meteorite ended up about 2 miles away, out closer to a canyon out there called Canyon Diablo. And it happened to have been found out there in 1908 by a guy by the name of Samuel Holsinger. And I love this story. It's ridiculous. Because apparently when Holsinger found this meteorite, he actually figured that he could pick the thing up, put it in his saddlebag, and continue on his way. Now, a couple things with that make it utterly ridiculous. The meteorite is 92% iron and 7% nickel. It's heavy. That chunk on your screen weighs 1,406 pounds. So you can imagine how quickly Holsinger realized he was not going to be able to pick that thing up. So he actually had to come back to that thing with a team of guys, a buggy and a mule, and they actually dragged it back to the crater. There's actually a photo of that inside the museum as well. I could not find that for the tour. It's really old and granulated picture. But with that, that does it for my presentation. I'm certainly sure that you guys all have remarkably good questions for me. So hit me, folks.
Thanks, Mike. So you can stop sharing your screen, and there are a lot of questions for you on the doc. And I can I'll start sharing the slide for you. So you can go ahead and start answering the questions.
For me. Oh, this is fun. All right. Well, I promised to answer this question. So let me get to this one first. What do I have a favorite meteorite? No, I don't. But I do have a least favorite meteorite. So I have a least favorite one because Meteor Crater has several meteorites. And I was asked to set some of them up in a private display for the upcoming VIP. So I had to drag a couple of these meteorites across the museum floor, which was quite an ordeal. One of them, though, was about 600-ish pounds, approximately, and we weren't able to pick it up. So we were setting the thing down, and next thing I know, I am shooting pain going through my foot. Meteorite was sitting on my toe. Everybody else in the room was laughing and thought it was the best thing in the world. Yeah, that was a lot of fun. So that's my least favorite one. Let me see. I have one from Ria's mom. And she would like to know what environmental impacts were caused by the meteorite. So, what's interesting about this, there's two parts, and I'll get to this one first. Were caused by a meteorite. It's really dependent on the size of the object, I've discovered in my research. So, for our meteorite, it was 150 feet, and it was traveling at considerable speeds. So, this 150-foot meteorite ended up hitting the ground with a force equivalent to a 20 megaton bomb, which means absolutely nothing to me. And if you're like me and you're wondering what the heck I'm even saying, I have this great visual. Now, the best way to break down how powerful a 20 megaton bomb is to take dynamite. Fill up the dynamite inside of a train boxcar, and then just keep repeating that process over and over and over again. Until, in fact, you have made a train that stretches from LA to New York. That's actually how much explosive power this meteorite had. So it dumped out tons and tons and tons of debris out into the air. It generated a fireball for about 6 miles out in every direction, which in fact, if you ever go to Meteor Crater, there's actually a gas station about 6 miles down the road from the crater itself. So it's a pretty good marker for you guys to see how powerful that fireball was. Then up to about 16 miles away, and you're being hit then with hurricane force winds from this site, which are actually flattening out the surrounding vegetation, any animals that were there. And not only all of that destruction, but there's actually creation in this. Because what's fascinating about the crater is there's actually evidence of water being at the bottom. There's a red circle directly at the bottom that doesn't necessarily fit in with anything else in the area. And that red circle was caused when the meteorite actually hit the water table. And that water then just caused it to seep up and form actually a lake at the bottom of the crater. So it made its own brand new ecosystem out in the middle of the Arizona desert. That water table doesn't exist anymore, or that high anymore, because the environment has changed. It's actually dropped quite a bit. But yeah. Now, could there be any chemicals introduced from outer space? And yeah, okay. So this was talking about a meteorite that fell through a woman's house. I don't know of any chemicals that would end up that would cause any sort of harm, because these objects are getting superheated. So I'm sure that they're relatively sterile. So if you find one, definitely pick it up. It's worth it. I've got one. Hope that answers your question. Now, let's see, what other questions? I like this one. How can we find out how old a meteor is using the materials it's made up of? So, I like this one because it's not quite as cut and dry as let's just get an easy carbon date off of it. Because the best way, and actually the way that they figured out how to date it, is using composite materials like lead and uranium that make up part of the meteorite. If you did your math, I said 92% iron and 7% nickel, which is in fact only 99%. The meteor actually contains 80 other trace elements. So some of those are actually uranium and lead, which hold dates better. Well, if you wanted to go back that far, their breakdown is much slower. And that's actually how they figured out the age of this thing. They had to sterilize part of the meteorite from this site, make sure that it was cleaned and back to essentially as close to conditions in space as possible. And they were actually able to figure out, using those two composite materials, that it was about 4.2 to 4.6-ish billion years old, which is actually how they guesstimate the age of the planet, by using meteorites and asteroids. Hope that answers your question. Let's see. Can you tell us the story about Sue? I could. How long we got?
Give us the Spark Notes version.
Spark Notes version. All right. Spark Notes version is that Sue is one of the best preserved tyrannosaurids that we actually have, which understandably makes her very valuable. And I say that because there was a legal dispute on where she was actually found. And she ended up getting seized by the government and then sold off at auction. And there was a concern that she was going to end up in private collection and what have you, but ended up being bought by the Chicago Field Museum. So it's a lot of highs and lows. I'm glad that she's out on display for everybody. If you have not been to Chicago Field Museum, definitely check it out there. She is definitely a highlight. also at the Chicago Field Museum, they have a slice of Meteor Crater meteorite that you guys can check out as well. So now you know. Let's see. What else do I have? Get that. That. Can we use the materials from meteors as materials for making things on Earth? What kinds of materials are found on meteors? Can they be used as resources in the future? Fun fact, you actually can use meteors for everyday objects. I believe if I recall this correctly, in King Tut's tomb, they actually have a dagger that is made up of iron and nickel from a meteorite. So, yeah, you can. What kinds of materials are found in meteorites? A whole bunch, as I mentioned before. Like the one in the meteorite that makes up the one from a meteor crater is 80 other trace elements apart from iron and nickel. So it's a lot of common materials. It's nothing, no materials that are kind of extraterrestrial in nature that we never find out here on Earth. So it's certainly possible. I've heard that possibility that people want to mine iron and nickel or materials out of meteors and asteroids. It's all very sci-fi for it all, but hey, why not? Have I ever visited an impact site for research? I have. The only impact site I have been to is the crater itself. I have not been to anything like Chicxulub. We were talking about the Vanderfort crater. I haven't been to any of those. There's about 198 known impact sites on the planet. And I'm sure that there are way more because we get hit with tons of debris every day. So, possible I'll go to another one. Why not? Are people still studying the crater to this day? Yes. We do have, every once in a while, we have NASA research programs that come out. Nothing came out while I was there for research purposes because we were right in the middle of the pandemic. It was a terrible shame. But definitely still research going on. It's not just totally forgotten about and people feel like they have enough data. Are there any other well-preserved sites? Not to the nature of Meteor Crater. The crater itself is a relatively small one in comparison to ones that you might think are large, like the one that killed the dinosaurs in Mexico. It really just ended up landing in a very good location that has preserved it pretty well. As far as I know, it is actually one of the better preserved ones that I can think of. Let's see. Everybody's asking really good questions. Far more questions than I usually get on my tour groups, let me tell you. What is the largest impact site? All right, so I touched upon this for a second. It is actually the Vanderfort crater, which is the largest one. It is approximately 99 to 186 miles across. And yeah, that's right, this one. And what remains of it is actually in South Africa. Think about that one for a second. 99 to 186 miles. Meteor Crater is only 1 mile at its widest. Like, is there any iridium at this crater? You know, I actually have not found any research on that. I've gotten some of the work from the geologist who comes out there, Dr. David Crane, and I've torn his book apart trying to find that answer for you. And for myself, I actually cannot find it. I'm sure that in some capacity it has to be there, but I myself have not been able to come upon that answer. Did anything go extinct with this impact? So, I like that question because naturally people get very concerned. So this hit about 50 to 70,000 years ago. So we're actually living proof that nothing really went extinct from this impact because our relatives were already walking around this planet. This is a pretty small, very localized impact site that definitely killed any animals that were in the area, but not anything on a mass extinction level event like the one that wiped out the dinosaurs. How does, and let me tie into that one as well, how does this crater and meteor compare with the one that killed the dinosaurs? Well, Chicxulub was caused, from my recollection, an asteroid that was about 6 miles in diameter, which, for size comparison, Mount Everest is about 5.97 miles high. So it's actually absolutely massive. Meteor Crater was caused by an asteroid that was 150 feet in diameter. Relatively small. So it's easy to grasp the size of Meteor Crater because you can visually see it right in front of you. But for Chicxulub, it's so massive and so well covered up by the rainforest and or the Gulf of Mexico. It's actually difficult to see, and it eluded people for quite some time. And they actually didn't realize it was even there until the 1980s, when they actually found some shock quartz and material of the impact while drilling for oil. Hope that answers your questions as well. I like these questions, everyone. You're all doing great. Where other cool geological sites are near Meteor Crater? Wow, that's a tough one because if you've never been to Arizona, when you should go, because there's quite honestly not a shortage of things to do. So there is Sunset Crater National Park. That's a relatively new eruption site in the area. There's hundreds of volcanoes in the area. There's actually Humphreys, or the San Francisco Peaks, which overlook Flagstaff. You can actually climb to the tallest point, which is Humphreys Peak. It's about 13,000 feet above sea level. There's the Petrified Forest, which is actually not all that far away from Meteor Crater. Petrified Forest, for those that don't know, is also a national park. About 220 million year old fossilized trees out there in the desert. Really fun. I just went out there and very desperately want to go back. There's also the Grand Canyon, which, if nobody's been to the Grand Canyon before, that in itself is worth going out to Arizona. But a lot of people will go to Sedona to look at all the beautiful rock faces out there. There's just so much to do out in Arizona, especially geological wise. It's in the candy shop. How did I get involved being a tour guide at Meteor Crater? Good question. I'd always worked in museums in the capacity of an educator. And being that it was a pandemic and I had just moved to Arizona, it was open. It sounded really interesting. It certainly was. It was a great enjoyment to be able to learn as much as I did in a very quick amount of time. But yeah, I'd always pass by that place every time I went out to Arizona and just never got a chance to visit it until I started working there. I regret not visiting it sooner. It's not just a big hole in the ground, as a lot of people will say. Killing it with the questions, everyone. Was Arizona's climate during the time of impact the same as it is today? About 50 to 70,000 years ago, it was actually sitting in an ice age, which meant at the time we were getting more rainfall, and the water table, like I mentioned before, is actually much higher as a result. So when you go out to Meteor Crater today, and I hope everybody here is from the East Coast, because we all have a very good understanding of what grassland looks like. But when you go to Meteor Crater, they will say that the surrounding area around you is a grassland. It's dry as a bone. The only thing that really grows out there very successfully are plants like juniper bushes, which don't need a tremendous amount of water. In fact, some of those juniper bushes are so hardy that they've lived over about 700 years. But at the time of impact, there were more forests in the area. It was more sagebrush, much more grassland. It kind of would look, I guess, in an image like a savanna almost, where you have creatures like mastodons, mammoths, sloth, bison, all roaming around that area at the time. Does Meteor Crater provide internship opportunities for students? I sure hope in the future they do, because that is a tremendously good idea. But presently, at the moment, they do not. But hey, you can always pitch in that idea. They'll take you up on it. Okay. I get this one quite often. There's a lot of archaeological sites out in the area. Are there any at Meteor Crater? Yes. Personally, for me, I don't like to mention them because I've seen firsthand that once people do know of these sites, some people can be quite disrespectful to them and cause vandalism to the sites, which is rather tragic. There are ancestral Native American sites at the crater. They're nothing permanent. They're non-permanent settlements. And the reason being is, as I mentioned before, there's no water. So you actually have to hike about 20 miles one way to get water and then hike 20 miles back. So it likely was nothing more than just a layover spot as they were commuting across from other sites. But nothing permanent out there. What is the most surprising thing that I found at Meteor Crater? This is a good question. I don't know what the most surprising thing I've found at the crater would be. I spent an awful lot of time trying to find a rattlesnake out there. I will say the most surprising thing I've witnessed out there are the rains. Because those rains, we will shut down tours and we'll stay inside. And I was right in the middle of an indoor presentation with one group, and this was shocking to us all, no pun intended. But the lightning started to hit right on the crater. And quite literally every single person in the entire theater got up, including myself, to go sit by the window and watch the lightning hit the crater. That was pretty surprising. And a whole lot of fun as a staff member to watch that. Let's see. Everybody is doing such a good job on questions.
I think there's one more question for you, and I can read it to you. What are the best areas for hunting meteorites?
Well, believe it or not, I would actually say it's probably your own backyard. Now, everybody's probably going to be thinking, like, what the heck? Why? Hear me out, folks. We get hit with tons of meteoritic debris every single day. Those shooting stars that we see sometimes in the night sky are technically considered meteoritic debris. Some of those substances, while they may not be as glamorous and hit the ground and cause massive impact sites, some of those objects actually make it to the ground as tiny fragments. And some of those may be magnetic. So if you actually go to your backyard and overturn, don't dig up anybody's flowers, please. But if you actually overturn some loose sediment and take a high-powered magnet, you actually pull out some iron and nickel fragments as well as other metallic objects. And if you look under a microscope, if they're perfectly round, they're actually called spheroids. Those spheroids are actually leftover meteorite fragments. There's really no one individual good spot to hunt for meteorites because it's just relatively common, which is kind of cool.
All right, thank you so much, Michael. That was really interesting. And thank you to all of our listeners today, everyone who tuned in. Again, we apologize for the technical difficulties, but I think it worked out. I think everyone was able to hear you. So thank you so much to everyone and have a great night. Don't forget to check out our website for our upcoming events.